Let's take a look at question number 2. When it talks about the cereal maker making the packages for the cylindrical boxes, when we are talking about how much that will hold, we're talking about its volume. So we do know that it has a diameter of 8 inches and a height of 15. And we also know that we need these two to have the same volume. So we have enough information about the cylindrical one to find the volume of it, in which case we would then know how much the rectangular one needs to hold. So let's start by finding the volume of the cylindrical. So we have volume is equal to pi times radius squared times height. So we'll approximate pi to be 3 14/100ths. Times, if our diameter is 8, half of that would be 4 squared, times our height, which is 15. When we go to calculate that, we get 753 6/10 inches cubed. So now what we know is that the rectangular box also has to hold 753 6/10 inches cubed. And we know that it has to have the same height, so therefore it has to have a dimension of 15. Now, when we go to find the volume of a rectangular prism, the same as the cylindrical cereal box, it is the area of the base times height. Where that was a circle, the area of this base is a rectangle. So therefore, to find the area of the rectangular box, it's going to be length times width times height. So the only dimension of those ones that we know right now is the height, but we do know that it has to have a volume of 753 6/10. So that'll be equal to length times width times 15. So now we have a literal equation in front of us where we're going to use our inverse operations to isolate the length and the width. So we'll start by dividing both sides using the division property of equality by 15. And when we do that, we're going to get that length times width is equal to 50 24/100ths. So now, ladies and gentlemen, from here, we simply need to pick out a length and a width that when they get multiplied would equal 50 24/100ths. So let's say we pick 50 24/100ths. Then the width would be, Taking a look at question number 3, Cameron is holding a small rock. So we have to keep in mind, not quite a pebble, but not a boulder. So we're talking about a small dimension. So when we're looking for density of the rock, when we are talking mass, what we need to figure out is what would we use to measure the mass of a small rock, which would be smaller units. So as we take a look at our mass units, if we put them in order from least to greatest, we would have grams would be our smallest unit of measurement. Then we would have our pounds, because there's 2.2 pounds in a kilogram. Then we would have our kilogram, which is made up of 1,000 grams. And then last but not least, we would have our ton. So if we're talking about a small rock, we're talking about grams. Now, in terms of our unit of measurement, our smallest is millimeters, followed by centimeters, followed by meters. So again, if we're talking small, we'd be talking about millimeters. So therefore, our correct answer to this question would be C. As we take a look at question 4, we're working with a literal equation, and we're trying to find and isolate R. So the first thing that we would do is undo the grouping symbol, which is the division bar in this case. So we begin by multiplying both sides by R squared. That'll undo the division, leave us with force times R is equal to G M sub 1, M sub 2. And that is R squared. So now, to get R squared by itself, our next inverse operation to undo the multiplication would be to divide by F. Cancel that out, leave us with R squared equals mass 1 times mass 2, all divided by force. Now, to isolate the r, we need to undo squaring. So our inverse operation here would be to take the square root of both sides. So therefore, r would equal the square root of the quantity of m1, m2, all divided by f. All being taking the square root of, which would be answer choice D. As we take a look at question 5, the first thing we need to recognize is that for an equation to have infinitely many solutions, that means that our coefficients will be the same as well as our constants. So to figure out what would go on the right side of the equation, let's begin by simplifying the left side. So I'm going to use that distributive property, and 3 times 4w is 12w, and 3 times -2 would be -6. Combine like terms, that gives me 18w minus 6. So now what we know is that when we plug in our values on the right-hand side, when we do the distributive property, it also will need to equal 18w minus 6 in order to have infinitely many solutions. So if I need this to be a -6, and I know that I have to distribute it to a -3, the only value that I can distribute to a -3 and end up with -6 would be a 2. Now, in order to end up with 18w, if I have a 2 as what's being distributed, I need to think about 2 times what number would get me back to the 18w, and that would be 9w. So therefore, the two integers that we would plug in would be 2 and 9. Because now when I go through to distribute that out, I'm going to get 18w minus 6. Moving over into exponents and following our laws of exponents. Our first one is raising to a power. When we raise to a power, we multiply them. So 2 to the third raised to the -2nd would give me 2 to the -6th. Then I bring down my times 2 to the 4th. When we are multiplying exponents with the same base, our shortcut is to add the exponents. So -6 plus 4 would give me -2. A negative exponent can be expressed as a positive by taking the reciprocal and making the exponent back positive. So the reciprocal of 2 is 1/2, and that would make it to the positive second. Because of that, our choices would be 1 over 2 squared, 2 to the -2nd, as well as we saw the step of 2 to the -6th times 2 to the 4th.